Keeping up with security issues across thousands of web assets without the right approach to web application security is a daunting task. Get ahead with web vulnerability scanning automation from NetSparker, a leader in dynamic and interactive application security testing known for its ease of use and accurate results. Detect a wide range of vulnerabilities in all legacy and modern web applications, address security bugs at scale by automating the confirmation process, automatically prioritize vulnerabilities, and assign actionable tickets to the right developers in their native workflows for rapid remediation. For more information on how to scale application security with ease, visit securityweekly.com/NetSparker. Qualys has brought together vulnerability management and patch management, letting security teams discover vulnerabilities and apply patches immediately, all within a single, unified app. Sign up for a free trial of Qualys VMDR, vulnerability management, detection, and response today at securityweekly.com/Qualys. Security Weekly is more than happy to announce that we'll be at InfoSec World 2021 in person on October 25th through the 27th, 2021. Our annual partnership with InfoSec World is extra special because we're all on the same team. We're all part of the Cyber Risk Alliance. That means Security Weekly listeners and InfoSec World attendees get to see and hear from many of the Security Weekly team. And at the event, you will save 20% off your World Pass. Visit securityweekly.com/ISW 2021 and register using our discount code. Also, hey, if you want to stay in the loop all things Security Weekly, you can visit securityweekly.com/subscribe. You can subscribe to all of the shows on the Security Weekly network via your favorite podcast catcher or our YouTube channel. Sign up for our mailing list, join the Discord server, and follow us on our live streaming platforms such as Twitch. And now we're going to talk about the security news. Yes, that's right.
We are.
What do we got? What was big? What was the big story this week? We want to start with the big story.
Yeah, get it out of the way.
I mean,
What was the big story this week?
Probably Kaseya. I don't know how you say it. Kaseya.
Kaseya.
Kaseya?
Yeah, it's Kaseya. They were actually a sponsor on the Security Weekly network for a while. Yeah, they had 5 or 6 vulnerabilities that were disclosed, and I think the story is they were disclosed and fixed, and then people didn't apply the patches quick enough, and then ransomware ensued. Right? One of the is that true, Lee? No, they get the timeline
very
wrong.
close. So they had fixed all but one, the last of which was scheduled for a June patch rollout, and it was that last one that was the 0 day.
Was that the remote code? Was that the RCE?
Yep.
Yeah.
I mean, I could find the CVE of it, but basically they got all these 6. They prioritized one wrong and they got nailed. I mean, what do you do? And because other than that, they were working with the folks that disclosed them. They were verifying that they were fixed. As they fixed each one of them, they were being on the vulnerability disclosure front. They were nailing it, except for the priority. I mean, what do you do?
Yeah.
But if they'd prioritized the one, maybe the other one that they downgraded would have been the one. So maybe they were screwed either way.
I had the list of them. There was like a cross-site scripting, a SQL injection.
Yeah.
And some other ones. But obviously the most impactful was the remote code execution.
Yeah.
Which then, I mean, there's like a zillion articles on this story.
Yeah.
That cropped up out there.
Which almost makes me not want to talk about it. But
yeah, I know. Like I feel the same way. Like when I go through stories, I'm like, I can see a trend here. Like everyone's talking about this. Like maybe we should talk about something different, perhaps.
Perhaps.
Well, there was a cool bit though to this, and that when they shut down to complete that patch and deploy it, they also re-architected their network. And then they rolled all that up into customer recommendations, and they went live before they gave the patch out to customers to make sure it all kind of worked. So that's like we're eating our own dog food before we hand it out. That's pretty darn honorable. I mean, yeah, I'm with you. I don't want to play the heck out of the top of that story, but they did do some nice things. I'd like to see more of that.
Well, yeah, let's let that be the emphasis. They kind of were doing the responsible thing. They did what they could. We can't knock them
that way.
for what they were doing. in systematically approaching multiple problems. And they still got bit, but that's the reality of security.
Yeah, they weren't just sitting back going, like we're not going to patch those things, right? They were
No.
That's not us. That's not real. That doesn't exist. Go away.
They were super. It seemed to me they were super motivated to get all this stuff fixed and get fixes out to their customers. So yeah.
Enough of that.
And I mean, it happens. I think some of the articles, Lee, I think is in your article, right? Like. Some of the recommendations, that might have been one of my articles on ransomware, right? Like one of them was like, don't get malware, right? But the other thing was, like isolate your stuff and minimize the impact. I mean, back to our first segment with Scott. I mean, we talked, Scott, and I agree with his approach, likes to talk about being proactive and having that maintenance too, but also I think minimizing the impact is important. In short of, I mean, we can patch all day long and still not get everything in terms of a patch. Like we're not going to be able to patch everything, and there's going to be 0 days, and there's kind of like that middle ground right after prevention, so to speak, that like you just kind of minimize the impact, right? That configuration in your architecture should help to minimize the impact as well. So I think there's some onus on the vendors to do everything they can, but even if they do, there's the onus is also on you to minimize that impact. We talked about that with SolarWinds. We talked about isolation, hardening, the buzzword of zero trust. But how does that apply? That means a good architecture and good teamwork, I think, are the two main ingredients to having a good security architecture.
Well, I'm glad you brought the first segment up again, because I was thinking about it then and decided not to get into it. But to me, the essence of security is not locking down everything, hardening everything, being up to date on patches, and doing all the stuff that you necessarily need to do. Security to me begins after you've done all that. How do you focus on detection and response, minimizing the impact?
Yep.
Because the reality is something's going to get you. We could argue whether that philosophy works with ransomware, because once it's happened, it's happened. Late. But to me, the essence of security, and I've talked about this. There was a conference talk I gave a couple years ago in the pre-times that talked about, there's so many things that we focus on in our industry and we spend all of our time on, to me, is just the table stakes. It's like that's just the job of IT, patching, finding vulnerabilities, writing secure code. That should just be stuff that's done. Then security kicks in, and it's the monitoring, it's the detection, it's the response, it's figuring out that something is going wrong and doing something about it. Given that, I think the trend is apparent, despite everybody's best efforts, you're never going to be completely there in terms of a secure network, impermeable, and yet that seems to be what most of the industry focuses on. You got to buy one more thing, you got to get this, how did you live without that, you got to have it. Even the idea of you need to do something with firmware, I agree with that, but to me the problem is, how do you motivate companies to actually do something about that and make it ingrained in their business model, how they're doing business. And again, I would dare say updating firmware is not a security issue. It's something you should be doing as part of your IT operations.
Yeah. IT hygiene, right? I mean, going back to Darknet Diaries too, episode 96, which we didn't talk about with Jack, is his latest interview that he has, or episode he has posted up there. It's called The Police Station Incident. I won't spoil that because it is the most recent one.
Thanks.
But when you get the lesson from that, it really comes down to like just really good hygiene. And the last 60 seconds or so when they're describing like after everything happened, what they did to fix all the issues, I'm like, that's the real lesson. Like if you listen to any part of that interview, you listen to the last 60 seconds and it's like, when we fixed the process, we fixed the procedures, we fixed how we operated, the operational aspects of it. If they had done that first, they wouldn't have been victims of.
Well, there's that nasty word again, process.
Yeah.
It's all, we talk about people, process, and technology. and I'm broadly being generic here. I've heard countless talks where people talk about, well, people are the weakest link. We've heard that for years.
Yeah.
People. And yet we focus on the technology because that's something tangible and we can buy something and say it's there and we can do something. But we really don't have a good handle on the process yet. And yet, to me, that's the biggest problem.
It's the least sexy.
It's the least sexy.
Because you can't go buy a product to fix your process.
Right.
You can buy a product that helps your process, that supports your process. But you can't go buy a product that's going to define and implement your process.
Right.
Is that true?
But you can automate it.
You can automate it, but you got to define it first.
Right. Well, and that's what. Well, it's funny you bring that up because this is not about me, but I give another talk where I talk about people, process, and technology. But the part that to me is overarching to all that, what you're touching on, is purpose. Why are you doing any of these things? What is it that you have of value that you're trying to protect? And how much do you care about losing that? And in the old days where I come from, it was all about the data. We've only introduced more issues with all the advances in technology where it's not simply about the data anymore. There's other aspects and elements. You could argue that it's still data, but
it's all about the information, Marty.
It's all about the information. Exactly.
I mean, it still is, but it's also about the operations that store, transmit, and protect that information. And that's what I think is the interesting thing about the latest trend in the culmination of the attack in ransomware is it's preventing you from getting access to your data, right? So, I mean, it is about the data, but it's also about how you're handling your data, transmitting, processing, accessing your data. It's attacking more of the operational aspects of it than the data. Because like we talk about PCI and data breaches, it was I want to get access to your data because your data, when you talk about payment card information, is credit card numbers, and those are valuable. And I'm just going to steal it, right?
Right.
Now we flipped that. We've talked about this, right? We flipped it and go, I'm just going to lock you out of your data,
right?
And that's
well, and to put it in the terms of the data security triad, which is what I grew up on: confidentiality, integrity, availability.
They're attacking the availability.
I'm making up the numbers, but I would say 95% of our industry is focused on the confidentiality. Yeah, and second is integrity, availability. I mean, if ransomware, and I know we have a story where we're talking about the White House has formed a ransomware task force or whatever.
Yep.
We haven't really tackled availability very well, at least in the private sector. I'm not saying that we did it well back in the DoD days.
Well, we all knew you had to have backups.
Yeah. That takes care of it.
Just an ode to another podcast with Jeff Moss, Malicious Life. Jeff tells a great story about backups. And he was like, dude, it was like back in the day, and I saved up for this hard drive, and I was backing it up, and then it died. And the restore process, if you remember tape backups, was like rolling the dice at a craps table, right?
Oh, yeah.
like I'm talking like 20 plus years ago, restoring from old tapes was... you roll that dice and it's about the same odds that you're going to get your data back. And he's like, yeah, I didn't roll a good hand, basically, was the story that Jeff tells, right? Which is kind of actually kind of funny considering his first conference was in Las Vegas. But
that is funny.
And there was reasons for that, too. Yeah.
Yeah.
That's some interesting things about DEF CON, right, in that interview on Malicious Life. So it was a pretty good one. I liked it.
Yep. You're reminding me of it was about a year ago, I was rebuilding a system. I'd made a backup. I'd put it on a disk that I had encrypted. And then I forgot the password. So after rebuilding the system by other means, I got almost completely done. And I found where I stored the password for the backup disk. That's a level setting moment, don't you think?
You wrote it down on a sticky note.
Isn't like RAID a backup? So I'll tell you a story that happened today. We had a server. It was actually given to us, right? It was kind of like one of those old decommissioned servers, which is why I brought it up a couple times on the show tonight, because it just happened like yesterday and today. Old server. It was configured in a RAID array. We went to install Linux on it, and it just kept failing and kept failing and kept failing. And last night at dinner, I was talking with Doug, and he was like, check the array. He's like, if that server kind of got thrown around, you moved it, and it's really old, he's like, some of those drives could have failed. And I'm thinking, like, but it has RAID. But it turned out there was 8 drives in it, and the best I could tell, 2 of the drives had failed. So I had to pull 2 of the drives, which, and I was explaining to the intern, like, there's only so much redundancy in the array that can store like the extra data that's corrupt on the other drives. And like essentially we ran out of space. Right. Now I had already backed up thankfully, I had already backed up the server, decommissioned. I didn't need anything on any of these drives. But if you did, you'd be screwed because now I had to pull 2 of the drives, and it was like, you got to rebuild the entire array. So I had to like rebuild everything from scratch. I got 6 working drives. 8 I had to pull, and all data is gone. So a backup is only as good as your ability to restore it.
Yep.
Oh, but on the government, it was the White House announces a ransomware task force.
Yep.
I don't want to poo-poo the efforts to combat ransomware, which I think really as we've talked on the show, is about combating good computer security, hygiene and architecture, a good defense, understanding the adversary and protecting our assets, right? And I guess my kind of gripe is, the White House seems to be, and I don't want to fault them too much because they are paying attention to cybersecurity, which I think is really important and really good, but they seem to be really, like, when you read the executive orders and some of the appointments and the things that the people who are appointed in these positions for cybersecurity for the U.S. government are saying, they're really heavy on the messaging of information sharing. I don't think that's a bad thing, but I'm like, what are we doing to put focus on the prevention of ransomware and the disruption of ransomware actors? Information sharing is a part of that, but I feel like it's the focus, and it's getting too much of the focus because information sharing only gets you so far. Like, that's basically, in my assessment, like telling everyone, like, here we're breached and here's how it happened. Like, that's great. Like, but what are we doing to prevent those? And what are we doing to, like, take the fight to the threat actors that are enacting this ransomware in our systems? Yeah,
that was my immediate impression when I first read the EO when it came out. Yeah, however many months ago. It's like, wow, they're talking all about information sharing.
A lot of it was about that.
And on Security and Compliance Weekly, I forget what episode it is, Johnny will tell me in a few moments in my ear, but we interviewed a buddy of mine that used to work in the pit, and he went out into the commercial sector, and he did a lot with, he basically helped start the ISACs.
Yeah.
And he spent a lot of years in financial services. So he was in basically
important aspect. The ISACs are amazing.
It's important.
It is,
but yeah, there's something about it that's like you're missing the point. That's already too little, too late. I mean, I understand it. I guess theoretically, in terms of if you share what's going wrong, you help other people go fix problems.
And that's the thing. I mean, but it's very similar to Ring. I don't know if you have a Ring doorbell, which is one of our other stories, but like it tells you, like, after another incident has happened. So I'll get a Ring alert that goes, the scariest one I got, someone captured on their Ring, someone in like a ski mask with a rifle walking on their property.
Wow.
That's scary. Like, good that I know about this particular threat actor, but it was after that had happened.
Right.
So, like, it doesn't speak to the, even if I know or don't know that's going to happen is irrelevant. Like, have I considered that threat? Have I done the threat modeling to say, well, like, what if that happens, right? How am I going to call the police? How am I going to make sure my cameras are working? How am I going to make sure I'm protecting my home? I have to do that stuff before that threat actor in a ski mask shows up on my front lawn. I mean, great that there's information sharing that, like, almost instantly I get that alert that happened.
Right.
That's good. But it's just one piece to the puzzle.
But if we're trying to prevent ransomware from being effective, I think we're back to talking about all those non-sexy things.
Yes.
That you just, the good hygiene.
Right. The inglorious purpose.
And all the stuff that you should be doing anyway, but for whatever reason you don't. And part of it, I think I was thinking about this during the first segment, was we've sort of conditioned all of our professionals in the industry in IT and security to just put out the fires. We're constantly putting out the fires. What's the loud screaming problem that's happening? We don't ever have the time to go back and do all the good hygiene. Some organizations do, but the majority of understaffed, underfunded, overworked organizations, all they have time for is whatever's the next big thing that's the next dumpster fire that's burning. So how as an industry do we help retrain and shift the conversation towards the, all that stuff that we don't like to talk about and nobody will get to
do. But I think a lot of that speaks to technical debt, Jeff, right?
Yeah.
Like I even think of it when we're implementing physical systems here. And a lot of times we throw stuff together and run cables and all that stuff, and it's kind of messy. And I'm like, that's physically part of our technical debt, because at some point we got to go clean some of that stuff up. I mean, it's the same thing whether you're deploying to the cloud, rushing out an application, you're incurring that technical debt. When something's working and you leave it alone and you don't touch it for years, you've got a lot of technical debt to clean up. And I think that for me, that's one of the pivotal things when we talk about the insecurity in our organizations. That's just very striking to me, is that it usually comes down to technical debt biting us in several different ways. Security risk, operational risk, a lot of it's technical debt.
Yep, that's true.
One of the interesting things I saw today that I didn't put in the news segment was that CISA released a site called stopransomware.gov, which talks about, it defines ransomware, what to do if you've been hit, and how to prevent it. It looks like it's still growing. It's fairly light, except on the what is column.
Is that a tool they released too? That's like a survey, like a question.
That's a different one. They released that survey separately, which is like a ransomware preparedness assessment tool.
Yes.
Try and say that fast.
Right. And it's written it's written for like Windows 95 or something like that. We covered on ESW. I don't know why they did that. It could have been a website, but they released it as
because like you said earlier, they're repurposing stuff that still works and still. I mean, this is there's not new solutions to these problems. Yeah. The solutions have been known all the way back to the Orange Book.
Which was in Hackers, by the way.
And really, in their prevention, I think it was the Red Book. They've got good security practice habits, like we were talking about. You may not agree with the list, but they're starting with the basics, which is good.
Well, it's starting with the basics, but it's also who's on the hook for doing it. And there's too much...
You mean accountability?
Well, not even accountability, but just responsibility. I mean, there's a perception in organizations that security is done by somebody else. I don't have to do it.
In the security context, what's the difference between accountability and responsibility?
Whether you get fired or not?
Yeah. Blame?
Yeah.
Where's the buck stop?
It's my responsibility to patch these systems, but if I don't, I'm accountable for them, and I could get fired. That's it. I never thought about the nuances and the language behind that, right?
Yeah.
I mean, I think there is a difference in theory, maybe the one or the other, and we could probably muse over it for longer than we need to.
Yeah, like we're getting very philosophical.
When is it management's responsibility versus the practitioner's responsibility? Because the practitioners mostly are going to just do what they're told to do. And of course, the organizations that I've been to over the years that were, in my opinion, the most secure were the ones where there were people that were going above and beyond because they knew that they needed to do it. Whether it was their resposibility or not.
They didn't want to be held accountable, therefore they took responsibility for it.
Yes.
Yeah.
Enough of that. We're getting we're getting way too deep into the Balvini.
Lee, I want to talk about I made a joke about Linux on the desktop. Largely because I'm a Linux user. I run Linux on all my desktops for a lot of reasons. I think control, which also has an element of responsibility to it as well, and there's a lot of other reasons as well. But Microsoft came up with this new release, and this is where I predicted, and I have to admit, I heard this on another podcast, and I think it was on the Twit network, they were talking about the future direction of Microsoft. And I mean, they were really of the opinion that Windows 11 wouldn't happen, that Microsoft was all in on what now I'm learning is called Windows 365 Cloud, that the operating system would be kind of irrelevant, abstracted away, that the Microsoft experience would be exactly what is described in my article number 1, the Windows 365 Cloud, that you could run all of Microsoft's applications in suite on whatever operating system you wanted, that it would be hosted in the cloud, it would be a cloud-first experience with your Microsoft products, and it'll run on Linux. It'll run on an iPad. It doesn't matter what operating system or hardware that you have.
Or firmware?
Or firmware, right? You could have this Microsoft experience. ZDNet ran an article and was like, Microsoft just blew up the only reason you can't use a Linux desktop.
Right.
And I was like, this is the year of the Linux desktop. Or maybe next year still. But I think this is kind of exciting. I like this direction for Microsoft.
I can remember, and I think I was still in the office that got reorganized into the pit. So we're talking early 90s. We got it wasn't Linux, it was Apple, but it would emulate the Windows desktop.
Yeah.
And we thought that was cool.
Yeah.
And most Linux,
I've been there.
Most Linux interfaces look a lot like Windows these days.
No, and I've been there, but this is exciting because it gives you that experience independent of the. It's not emulation. I'm running this software,
right?
And the cloud is my.
But the problem back then was all the apps and software that was written for Windows wouldn't necessarily run
in the emulation. Emulation is a bad way to solve the problem, in my opinion.
This looks like to me like they're doing Windows desktops hosted in Azure, and they're going to run all the Microsoft apps, and they're working on getting more of the apps. That there's compatibility tells me it's not quite a full Windows or something's different about it.
Sure.
But with and all you have is a display. You're a terminal.
Yeah. You're back to the mainframe model, right? Yeah.
And I was thinking, well, what about when you're disconnected? But for most of us, life stops when we're disconnected. So maybe that's not a showstopper anymore.
Yeah. I agree, Lee. I think from security, this could be a very positive thing as well. It puts the configuration and security back on the cloud, where it is largely today and should be, right? And abstracts that and what I love about it too is as we've talked on the show for years, we get into trouble in security with legacy applications. Now, if applications are being developed in this Windows 365 cloud, it's not tied to the operating system at all. And my hope is that when you're using a system like this, you can update the operating system and not have it impact your applications. That's a huge win.
Well, imagine being able to deliver the solution to everybody in the company, and if Paul needs 4 times as much CPU and memory as Jeff does, you've still got the same environment. You just change the settings on the virtually, and they make this machine the right size.
Right. Is that dissimilar from VDI? I still feel like VDI is not the right solution for this. This sounds like a hybrid between running apps locally and VDI, right? Like this sounds like somewhere in between.
It smells a lot like Amazon Workspaces, which I've used.
Yep.
But I suspect Microsoft's going to try and leapfrog Amazon in their offering. They're talking about multi-factor support. They talked about zero trust, and they were executive order compliant with all the buzzwords, which was kind of neat. But and I don't fault them for that. I mean, you got to look at where the buzz is and deliver on it. I just want to get my hands on trying it.
Right. I think Microsoft wants to get out of the operating system game. I think they realize long term that's not a viable financial option for them. I think they're better off licensing cloud applications, like this article talks about. And I think security wise, it's a much better play. And I think it keeps you sticky to the Microsoft environment, but doesn't care about I think that's a really innovative thinking on Microsoft's part. Also on Microsoft bug bounties, any guess from July 1st, 2020 to June 30th, 2021, what Microsoft paid out in bug bounties? I put it in the notes so you could read it, but if you haven't read it...
I haven't read it. I'll guess 10 million.
Close. 13.6 million. Yeah, that's a really good guess, Jeff. I'll give that one to Jeff. Any idea how many security researchers that were paid out a bug bounty contributed to that 13.6 million?
I'll drop 10.
10 researchers?
No, 136,000 researchers.
136,000 researchers?
Yeah, because they don't pay.
It seems like too many.
Maybe 2 zeros.
No, that's too many.
13,000.
No, take another guess. How many researchers you think?
136. I'll go with that.
Okay. It was 341.
Okay.
So, like, if I do the math, provided my math is correct, and I suck at math, but so if you got 341 full-time employees at $150,000, that's $51 million that Microsoft has to pay out, right? So I was kind of like, what if Microsoft were to just hire all these bug bounty people and bring them in-house? And I used $150,000 as kind of like an average kind of salary, right? Because there's other costs other than the salary you pay. I like you to pay them benefits and get them computers and all that stuff. Right? FTEs cost more than the actual salary you pay.
It used to be the physical office space that you needed to actually put somebody at a desk.
That's not true, right?
That's gone.
That's gone. So
overhead. They call it overhead.
But I think for Microsoft, like economically, this still works out, right? Like if they have to pay $13.6 million to have a bug bounty program, and you got 341 people that contributed to it, that economically this worked out for Microsoft.
Well, what was the reporting period?
1 year.
1 year.
Yeah.
So I mean, it makes sense too because they may not have to pay that out. Whereas if they hired them as a full-time
and they have to,
basis,
it's a fixed cost.
They may or may it's a fixed cost, and they may or may not. It's like that's why contracting became so popular.
Because it's I agree. Because you can terminate a contractor after a certain period of time and put them on a short. So for Microsoft, this works out, right? That's not every company, but in this case, I think for large software companies, maintaining a bug bounty program is financially viable, and that may not translate to other smaller companies, but for Microsoft, I think it worked out when I looked at that. I was like, that's pretty good, right? Did Lee have to drop? Okay.
Oh, it's us then.
It's just me,
and I'm here, so I don't care how late we go.
That's just awesome. It's just we can just rant on and on.
We can go. Good night, Lee.
So I mean, I think you can pick on certain aspects of a bug bounty program, but I mean, just looking at this one kind of aspect of it, I thought it was pretty good for Microsoft, right? Like it helps I mean, they've got the budget. They could go hire a bunch more people, right? But they got the value from this program where I don't think they really have to change that.
And this is a program that was set up by Katie Moe, right?
It was originally. It's a good question. Does Microsoft still run this program themselves, or is this like a program? Like Microsoft's big enough, conceivably, they could have a program with HackerOne and BugCrown and have their own program.
Again, outsourcing.
Yeah, they could even outsource aspects of the program. To it as well.
Yep.
I think this is a big for bug bounties and for Microsoft. I think this is a win.
I guess I agree.
Encryption, since I have you
please
in studio with me, trapped in here in studio.
Yes.
Amazon rolls out encryption for Ring doorbells. What's interesting, Jeff, is I just rolled out a new Ring doorbell at my house. For a long story, Ring actually sent me a doorbell as a security person to kind of evaluate its value as a security device. They had sent me one. And I made some mistakes and kind of I lost the cable to my actual doorbell. So I have an AC adapter that's plugged into an outlet that provides power to my Ring doorbell.
Okay.
And it stopped working. And so my wife was like, I really like having that as a device in our home, so figure out what's wrong with it. And so the first thing I did was I tested the outlet. I'm like, does the outlet have power? Like, did I trip a breaker or GCFI outlet or whatever, right?
Right.
Outlet was fine. I'm like, all right, well, the next thing I'm going to test is the AC adapter. And I'm not the best with, Larry is way better at the hardware and, all that stuff. So, like, what I learned from Larry, I'm like, oh, I've got a multimeter. I'm going to go test and make sure that I'm getting, voltage and amperage from the AC adapter. Mm-hmm. And I got nothing. Like, I tested it. I'm like, I'm getting nothing. All right, so maybe my AC adapter's dead.
Right.
But you can remove the Ring doorbell, and then the Ring doorbell has a USB port, a micro USB adapter on it, so you can charge it. Mm-hmm. And so I plugged that in, and it didn't light up until tell me it was charging at all. So then I tried a different cable. I tried 2 different cables and 2 different power sources to charge my Ring doorbell. Nothing. So I came to the conclusion that not only is my AC adapter dead, my Ring doorbell is dead. Like, I need to order a new Ring doorbell and a new AC adapter, and I got that installed this morning, actually, before I left for work, and everything was fine. So I'm like, all right, well, maybe it was the lightning storms we had here in Rhode Island. Something got fried on my previous one, so I bought a new one.
Okay.
And then this article told me that, like, none of the footage from your Amazon Ring doorbell is encrypted. And I'm like, that's kind of creepy. Like, I'm getting creeped out by these devices in my house. Like, I've actually removed all of the Amazon Echo-based devices from my home because I don't trust Amazon.
Right.
I've got some Google devices left. And, like, slowly I'm taking those out. And my family's kind of like, on the fence. And I'm like, yeah, but privacy, it could record what we're doing, record what we're saying. I'm not comfortable with that. And so I've removed some of those devices. But the Ring doorbell is convenient. But then they came out with this feature in my story number 3. They're rolling out encryption.
Right.
And I'm totally all about this. Like, I should be the only one that should be able to view the footage from my Ring doorbell. And I should be the one to decide who I share that with.
Right. And
it sounds like that's what they've done. So they've rolled out end-to-end encryption. It uses public key infrastructure based on RSA 2048-bit asymmetric account signing key pair. Oh, right. So sexy.
It's sexy, and I haven't read the whole article. I read enough to know that they're using public key cryptography. So my first question is, okay, so the Ring doorbell, it's got the video camera. It's recording video.
And audio.
Two-way
audio, so I can talk to the people if I enable the microphone.
And is it an option that gets saved or stored?
No.
Or it's just streaming?
No, it does. I have to sign up for an account.
Okay.
And pay a fee to, I don't know, because I have Arlo and other services.
But the I don't do all this stuff, so the ordinary lay person that's using this thing is using their smartphone.
You have an app. Yeah.
You have an app. You launch it, and
you can say whether or not, based on motion, you want it to record the video, or if you only want it to record when someone pushes.
But you're just launching it to see somebody rings the doorbell, so you bring it up and look at the video to see.
When someone rings the doorbell, you get a notification on your phone that someone's ringing the doorbell, and you push answer, and you can converse with that person and see them on your phone, and it records that.
So my question is, where's the public key? Where's the private key?
That's a good question. I haven't enabled this feature yet to kind of know how I set that up, right? I would assume that I would hold the private key, and anything that it records is encrypted with my private key.
Right.
And then
or it's embedded in the app.
Amazon's encrypting it with my public key, and only I can decrypt it with my private key. Right. Yeah.
That would make sense. And
thanks to Diffie, Hellman, and Merkle.
Yep.
We don't talk about Merkle so much. We talk about Diffie and Hellman, right? Merkle was involved to a certain extent, and then Revest, Shamir, and Edelman. Basically, what they came up with was the prime number, factoring prime numbers,
right,
and the certificate authorities to validate that the public key really is Amazon, right? Basically, like if I want to buy something on Amazon, they're saying this public key is from Amazon.
Right.
That's what. If I had to please correct me if I'm wrong, because when you talk about encryption like that at a higher level, there's a lot. There's a lot of math. There's a lot more to it than I'm describing, right? But Crypto by Steve Levy really gave me the kind of tools to help explain that to like people that don't know what crypto is. Like, what is RSA? What is encryption? But that's how I think of it.
But to pivot on what Jack was saying, try to make it understandable. This is high level mathematics. Yeah. I don't understand it. I'm not a mathematician. To put it in lay terms, you've got a key pair. There's public and private. You can encrypt anything you want. Anybody can have the public key, and all you can do is encrypt.
Right.
The only way that you decrypt it is you have the private key.
Right.
And the math, which I only understand at a marginal level,
there's a lot of
has to do with prime numbers and our next article that we should talk about is quantum computing.
Sure.
But the security of it is in the difficulty in factoring large prime numbers.
So I've multiplied two really large prime numbers.
Right.
The keys are like what those numbers are.
Yep.
Factoring is figuring out, without knowing what those numbers are, what numbers did I multiply together to get that number. Right. That's how I understood it at a high level.
But for me as a former cryptographer, the weakness of any crypto system typically is not the algorithm itself.
It's the implementation.
It's the implementation, and it's the endpoints.
Yep.
So I
have to keep my private key private.
Right.
But that was
which is why I'm wondering where it is.
Well, and that was Diffie and Hellman. That Crypto by Steve Levy goes into a great story about how Diffie was like, I just need to split the key in two. Like, that's essentially public key. Like, that was the really foundation of it. Was before that, if I had a key and I encrypted some data, I'd have to share that key with Jeff.
Right.
Diffie's kind of revelation, which was also a revelation had at GCHQ by other researchers that couldn't disclose it at the time, they came to the same conclusion that it'd be really neat if we just split the key.
Right.
And that was the foundation. The RSA algorithm built on that and added in, the best of my knowledge, not understanding the math, was like using prime numbers and factoring of prime numbers to in the key process.
Right. Yeah. So we don't need to go into the math, but we do need to go into where is the private key and how do you protect the private key?
Typically, that's with a passphrase. They don't term it as a password. It's a passphrase.
Well, and what you're saying, what's happening is the private key is itself encrypted. So the passphrase
is the encryption key to the. Is there another encryption algorithm? Typically, I feel like we should know this.
Typically, I'll put it in PCI terms. Not that that's going to help anybody, but the private key, which is the essence of what you want to get at, if you want to break you get the encrypted data and you want to break it, you want to decrypt it, you need the private key. So the private key itself needs to be protected, and that's typically done with another layer of protection. This goes back to NIST, and they have extensive documentation on all the different types of algorithms and strengths and key lengths and stuff like that. But you have the concept of the data encryption key, which in this case is the private key. It's what's being used to encrypt the video, but that key itself is protected with what's called a key encryption key.
Right.
And that's typically unlocked with a passphrase, which is not the key in and of itself, but it's a part of the key that accesses the key and makes it able to, I don't know the details, and I'm probably getting it wrong to some level. But to me, for this particular implementation where you're trying to protect the video because somebody could intercept it and it's not encrypted, or if it's being buffered or stored somewhere, if you decide to store it, hopefully it's going to be stored encrypted now. The way that you get at it.
Yeah, I think you're right, because when you're capturing the video, like, is it is it unencrypted at a certain point and then encrypted with my public key? Like, at what point is it encrypted on the device, like as it's receiving video?
These are the types of
new one.
These are the types of questions you need to find out.
Like, is it in the camera? Like, is the camera like
does
on
the camera have the public key? Is it encrypting the video signal, which ultimately is just a stream of bits?
As it's encoding it, it would have to do it as it's encoding it, right? Yeah, it's a good question.
But it's probably happening in the doorbell itself.
It could be, but again, we get back to IoT, like how much processing power to have my Ring doorbell to do encryption.
Or is it being sent to some processor that's in the cloud that's sort of transparent to you, the user,
right? And
that's where it's happening.
So if I'm in between the camera and the cloud, is it being transmitted unencrypted, just stored encrypted, but transmitted unencrypted? Probably my guess, given the computing resources and bandwidth, right?
Mm-hmm. So the beauty of encryption is it protects the data as it's being transmitted, and the theory is, well, it's an encrypted signal. You don't have the keys, but the way that most cryptography over the years has been attacked is not breaking the algorithm; it's finding the key.
Yes,
and stealing the key,
right. Or even portions of the key. Right, with a lot of attacks are you can derive portions of the key.
Yeah,
that gets into entropy and all.
We could get into the weeds on that, and we probably shouldn't. We would start to bore.
There's a lot of interesting segments I think we could do on.
But I mean, I tell a story about PGP, and of course, in the early days of PGP, Phil Zimmerman got in trouble because he was producing cryptography that wasn't regulated and wasn't controlled by the entity that was responsible in those days, which was NSA.
Yep.
And they went after him.
And his problem was with the cipher, right?
His problem was that he was producing what was classified as materiel. It was munitions.
Yes,
it was being exported, and so that's what they were going after him for.
The government had issues with what Zimmerman was doing,
right? But
also on the technical side of that, there was issues with his early ciphers. What did he call that? He called a cipher the blender, something with the blender cipher or something like that. He based it on a Saturday Night Live skit we talked about a few weeks ago, right? There was an issue with his cipher. Yeah.
Right. But what the government went after him for and tried to prosecute him for was violating the export policy for munitions.
Correct.
But while I was at NSA, I know I've told this story on air before, so I'll go really quickly. We had a call to arms, stop the presses, everybody focus on coming up with an attack against PGP, because we had one of our customers that we were deeply invested in a multi-million-dollar encryption project. They came back to us and said, why do we need to spend millions of dollars on that when we can use PGP and it's pretty much free? Right. And isn't it just as good? So this call went out to find an attack against PGP, and there were some guys that came up with an attack against the PGP, but what it was effectively
really attack against the software and the user, not the encryption algorithm, right?
Right. Yeah. I mean, they found a way to steal the secret key. They found a way to export the key ring, is what he called it. So, and it was actually a phishing attack.
Right, like a Word document or something.
It wasn't Word, but it was WordStar or whatever one of the precursors was, and they had some embedded code that they found some unused bit space. And so if you opened an attachment, this code would install and execute, find the key ring, and send it out. And the story that I tell is that they were lauded as heroes. They'd saved the day for NSA. We'd found a PGP attack, and but when I heard a lunch and learn briefing when they were talking to just us peons that worked with them, and it was in our lab, they told the story of what they had done. It was really cool. I mean they put this payload into very small space in the document, but essentially it was a phishing attack. And I asked them a question. I said, wouldn't this work against our system, anything. I mean, you're not attacking the crypto itself. You're not attacking the algorithm. You're stealing the key, and that's always kind of stuck with me, and it's borne out in so many cases where you can have the best crypto around, but if you're not protecting the keys. And by the way, and I don't know if everybody knows this, I don't know if this is common knowledge, but certificates, TLS SSL certificates, are essentially the public key. Right. It's a key.
Yeah.
We call it certificates, but it's a key.
It's the public key.
And it's basically...
The CA is just validating the public key is coming from Amazon.
Yep. And it's enabling
as an example,
our HTTPS, our secure web traffic. It's doing the initial handshake so that you can establish a data encryption key that can be used with a symmetric key algorithm, because they're so much faster to execute than public key cryptography.
Right.
And I don't know where I'm going with that, other than the lesson to be learned is that it's not the algorithm per se, although there are attacks against the algorithms. Usually they're brute force attacks.
Yep.
DES was broken because of distributed processing. They defeated...
There's theories it was broken on purpose so NSA could spy on... That's where the book goes.
Whatever. I'm not
Jeff
go
is
there.
not saying this, right? But that's where the book is going, that it was broken on purpose so that NSA could spy on people. That's the kind of conspiracy kind of theory.
Yeah, I'm not going to go down that road. But all that to say is algorithms are typically, can you do the brute forcing? There's throughout history, even when it was machine cryptography, before it was digital cryptography, the cryptographic attacks were typically brute force. The Turing machine was just brute forcing. I mean, and they had some cryptographic tricks where they got a little bit of they knew what
the Heil Hitler thing,
they knew what the beginning of the message was, so that was a starting point, and that was a cryptographic
attack. It reduced
attack.
the key space, basically,
or it gave you some knowledge of the way the Enigma machine was. There was a series of rotors, and you could figure out very quickly what the initial settings were.
And Ed SCOTUS has one, which is why you mentioned that when you visited Ed, it was like a cryptological.
Well, he has
museum.
an Enigma machine. He's got various crypto devices. He's got Russian rotors from different. He's got all sorts of cool stuff.
He's a crypto nerd. He's a crypto nerd. Maybe we should bring Ed on to fully unpack.
Not for the Christmas hack, but for the holiday hack. Have him talk about crypto. We should do that.
Yeah, for SSL, because I always kind of thought it was interesting that if you were to do like a man on the street interview, a person on the street interview, if you were, and just ask random people like, "Hey, you work in security. Like, how does SSL work?"
Nobody knows.
Few people. It's a hard question to answer. It really. That was what that book kind of turned me on. Like, that's a really hard question to answer. To be able to answer that in English terms that people can understand. But then there's a subset of people that can actually understand the math behind that as well.
Yeah, and that's a good point, because the math is lost on most people. It's lost on me.
When I was reading the book, they were talking about the early papers, and I started Google searching for what were the early papers on the Diffie-Hellman key exchange, on the RSA algorithm, and you read the first paragraph. And then the next section goes into all the mathematical formulas. I'm like, holy crap, I'm lost already.
Right. Which, if we can loosely transition back to the news stories.
Yes.
You had an article about quantum computing. Quantum computers are coming. Get ready. What quantum computing does or will do eventually with public key cryptography is it enables the fairly quickly solution of that factoring the prime numbers.
Right.
So it blows up public key cryptography completely.
Because you can do enough math to reverse factor, for lack of a better term. That's not the right term, but reverse factor.
Solve it, decrypt it, crack it, whatever you want to, break it, whatever you want to call it.
You can do enough math to
Ironically, what it doesn't really give you a leg up on is traditional symmetric algorithms, where it's just one algorithm with one big huge key. Because there is no factoring involved. It's you've still got to brute force it, and it's still going gazillion possibilities.
So we could go back to symmetric key cryptography and be safe.
Well, that's the challenge, and the challenge is compounded because symmetric cryptography is it's faster, but how do you
operationalize that?
How do you distribute a single key to
how do
everybody?
I give you that key securely?
Right.
Yeah.
Especially when you're trying to do like a website and you want to have all your millions of users be able to do secure communications, secure web sessions. That's the problem that's and hats off to all the people that are trying to solve the problem, because there's a lot of organizations. NIST has had an open call for 3 or 4 years now to come up with new algorithms that are fast and work operationally. They're practical.
But interesting how that impacts cryptocurrency as well, which still uses that Diffie-Hellman style key exchange in the cryptocurrency, right? There's still a public-private key aspect to that cryptocurrency. From when I get the high-level description of how that works, like I'm like, oh, it's still using like Whitfield Diffie must be like, that's pretty amazing that they're taking what I developed, 40 years ago now, or 30 years ago, or whatever it is, right? And when did he develop that? It was in the 70s. It was in the 70s, right?
You were 40, 45 years ago? Yeah.
Yeah. And now applying it to currency, which must be a pretty amazing.
Yeah. But somebody will come up with a solution for it. I'm old school. I'm paper one-time pads.
Yeah,
you can't break them, but they're not practical to use. One-time key. Although there was several years ago, I was at RSA. I think it was RSA, and I was just walking the trade room floor, and I came across a company that was talking about doing one-time pad encryption for data storage, and they were using lasers to create the one-time keys. I'm like, I'm intrigued by this. I'm going to stop and talk to these guys. And of course, the people at the booth had no idea what I was asking. They're like, but the physicist that designed all this, he's here. He can talk to you. So we had a conversation.
That was a revelation that John Strand, Ed Scotus, and myself were at dinner at RSA. We were mentoring students. But Whitfield Diffie, and I want to say it was Revest, was in the same room, and we kind of looked at each other like, you guys should go talk to those guys. They invented like these cryptographic algorithms that we use today that enable e-commerce and all these things. We're very humbled to be in the same room as some of these folks.
And we forget that as especially in the hacker community, we like to go on and on about how we break things, but try building something that can't be
creating
broken.
Those out. It was an amazing story to me. Yeah.
But I guess the point that I would make as an aged manual cryptographer is, and I see this in PCI all the time, because PCI has requirements to encrypt data. But they also have a lot of requirements, and they're somewhat dated because they're written in the context of the way we used to do cryptography, let's say. But it's all about key management and key distribution, and it's protecting not the data, not the algorithms, but it's protecting the key. And man, that's really hard to do. Nation states have a hard time doing it well historically. Of course, NSA did it really well. But even NSA realized that you can have the best algorithms and the best designs, but it all falls apart in implementation if you're not doing key management and key distribution. The Russians, back when I was at NSA back in the late 80s, there was a famous espionage case, 2 guys named Walker and Whitworth. They were selling the keys to the Russians for like 10 or 15 years. And the only way we found out about it is one of them, I think it was Walker, was going through a divorce, and his wife blew the whistle on him.
I think I remember telling that story.
That's how it was discovered. So, if it wasn't for, if he had been better at taking care of his wife, who knows how long it would have been gone. And all the safeguards, all the protections, all the lessons learned by NSA over the years about how to protect and secure data and vet your people, it was all blown up because somebody just said, hey, I can sell this and make money.
On a lighter note,
I don't
know if you read the story, the funniest quotes about cybersecurity and tech. Two of my favorites from this one is from Brian Krebs.
Mm-hmm.
And Brian says, I've come to the conclusion that if you give a data point to a company, they will eventually sell it, leak it, lose it, or get hacked and relieved of it. There really don't seem to be any exceptions.
Yeah. I haven't had a chance. I want to dig into this because who doesn't like funny quotes?
Right. William Peterson said, whoever said that the definition of insanity is doing the same thing over and over again and expecting different results has obviously never had to reboot a computer. Again, it's one of the lessons I've instilled on our intern is that, sometimes to make shit work, you just got to reboot it.
Right.
Seriously, dude. He's like, I'm actually kind of amazed, how often that still works today. Just rebooting it is all you need.
Well, I was speaking of rebooting when we were talking to Scott in the first segment,
mm-hmm.
And he was talking about what's involved in the firmware attacks. I was remembering the countless times that I was at a customer side, a retailer, and I'm looking at the point of sale system, which is running a payment application, and it's all locked down, and all the mm-hmm. cash register clerk can do is log in, and you can't break out to the operating system because it's all contained. But I would have them reboot the thing, and it was running on, back in those days, it was probably running on Windows 98 or 95, mm-hmm. or maybe it was 2000, or maybe it was XP. But the systems which were running on older hardware would take maybe 20 minutes to reboot and boot
mm-hmm.
up. And all that time, I'm like, I can just halt. And I did. I interrupted the boot sequence and I was on as admin.
Right.
And I could do anything. And, you had to be there, but, how many, large retailers that have lots of checkout counters, or they have, something in the back, think a grocery store where they've got the deli counter, the florist, the baker,
mm-hmm.
Maybe they have I'm blanking on, the people that will do the parties for you, the party platters and stuff like that. The catering. Thank you. All these other people have the same systems that aren't out in the front where the video cameras are to make sure that the clerks aren't pocketing money and stuff like that. Lots of opportunity, and really not a good solution to fix that. You just had to kind of hide your head and hope.
One of the philosophical quotes from this article is from Steve Wozniak. Never trust a computer you can't throw out a window. It's very philosophical.
That is philosophical. I like the it. If you spend more on coffee than on IT security, you will be hacked. Yeah. And that reminds me of, I had a customer in my early days in the private sector that we would go to their, I'm not going to name the client, but they were a philanthropy, and they had lots of money, and they would invest the money in various types of research efforts and stuff like that. But you'd go to their headquarters, and the artwork that they had on the walls, they had really, really expensive artwork. They would bring in European chefs to cook in the cafeteria. I loved going there, and I always made awesome. Always made sure we had to take a break for lunch because the food was amazing. But the money they were investing in all that stuff, and they would have people that were getting the grants. They basically operated a hotel. They had a rat skeller. They literally had a rat skeller on the campus, and I'm like, all this money that's invested, and we're arguing.
What's a rat skeller?
A rat skeller is the one that I know about the most is at the Hilton hotel in Louisville that I always used to like. It's in the basement. It's kind of like a speakeasy.
Yeah. Okay.
But just a big banquet hall, but kind of dark and kind of look like you're in a crypt or something like that. This one at this
it's kind of like a club. There's one in Rhode Island. There's a restaurant called the Rathskeller.
And it's an exclusive club.
Yeah, but in the yard they have all these games they've got I don't know if it was when we throw the sacks in the cornhole. Yeah, games like that in the back, because it's kind of, it feels like a club.
There's varying degrees of it. This particular place, it was walnut paneling on the walls.
Yeah,
it was a very, like your ideal cigar club lounge. Kind of overstuffed leather chairs everywhere, and a bar, and the best liquor that you could find, and they invested so much money in that because they wanted to, the people that were getting grants were, university researchers and stuff like that, and they would bring them in and wine them and dine them and, make them feel comfortable. But, and that's an extreme example, but, there's countless examples of, money that's spent on things that don't really matter from our perspective.
Right.
And yet you struggle to get the budget to do the hygiene things, yet alone buy any security solutions. I like the one too. Someone cracked my password. Now I need to rename my puppy.
Yeah. Yeah. Right. Kiwi SDR. I want to circle back with Larry on this one to see how popular this one is. I've not used Kiwi SDR, software-defined radio, right? But basically, a few lines of code allow the developer to remotely access any device, enter its URL in a browser, append the password to the end of the address, and basically, you get access to the web interface. Wow. Like a very traditional backdoor. If you watch the videos in this article of the demos, in the interface, there was like a thing where you could run commands and basically execute operating system commands, like on Linux, like just run all kinds of commands.
That's really old school.
Yeah. And this backdoor persisted for some time and not only allowed you to change the configuration of the SDR, regardless of what hardware is running, at Raspberry Pi, whatever, BeagleBoard, which is another hardware platform, but allowed you to access the underlying computing device that it runs on, like essentially remote command execution, as well as like do anything that the configuration could do with SDR, software-defined radio.
I haven't read the article. Did they conclude or even hypothesize whether this was an intentional?
That's what I was wondering. Yeah, I couldn't find that in the article. I didn't read it like in any great detail other than to like see some of the demos, and I kind of skimmed through it. I believe this came from Dan Gooden from Ars Technica. They didn't kind of make it, as far as I could tell, didn't make any speculation as to whether or not like this was intentional, or it kind of seemed to me like they just put this in as like a debug kind of feature and forgot about it kind of thing, like
very common.
I developed like an initial version, like I'm just going to code this in and forgot to rip it out,
or conveniently left it because when people are having problems, they want quick access and they want the problem fixed, and this is the easiest, quickest way to get in. I mean, I don't know how much it persists these days, and I haven't done technical hacking in many years, but that was very common in the early days where we weren't really exploiting anything. We knew about the features that were unpublished and things that gave remote access in particular, and this is very reminiscent of that.
That's kind of creepy. So if you do run that software, make sure they did fix it. And remove the backdoor.
Does it require a firmware upgrade?
No, this is like software that runs on a device that has a software-defined radio device attached to it, right? So you'd get a Raspberry Pi, put an operating system on it, plug in the software-defined radio, and then run this software that interfaces with the hardware.
I had brought up the article. I don't know if you had a chance to dig into it. What was the title of it? Stop huffing about cyber retaliation.
I saw that.
Did you get a chance to read it?
I didn't read it, but I saw the headline. Oh, let me refresh. Is that in one of your stories, Jeff, or?
I didn't have any stories.
Oh.
It might have been one of Lee's.
I did see that. Which story is that of Lee's?
Search on huffing.
It's BC.
8.
his story number 8.
Story number 8.
Ransomware getting leaked sensitive information from 6 universities.
Maybe it was your story number 8.
My story number 8. Yeah. Stop huffing about cyber. Yeah, I did see the headline. I didn't dig into this story.
Oh, well.
Oh, well.
We'll read the article.
Yeah, retaliation is really interesting. John Strain and I have talked about this like so much. Like, you can't really, I mean, can you hack back? Can you not? Like, it comes down to attribution and all this stuff. And with all the talk about ransomware, the inclination is to go, well, we just need to like retaliate. But like, who are you really retaliating against?
Right.
And doing that attribution is so hard.
Well,
you get into international laws.
I guess I would say, and I'm certainly not expert on this or read up on it, but some things like retaliation are best left in the hands of the professionals.
Yeah.
Which in this case would be the DOD. And
John and I, Strand and I, are really of the opinion, if you're going to do that, work with law enforcement.
Yeah.
Help law enforcement. Have law enforcement help you. Make sure you got your attribution down. You know, I think Microsoft has done a good job of the retaliation in taking down botnets, right? Mm-hmm. But there's a tremendous amount of research and collaboration that needs to happen before it culminates in we're going to take down this botnet, right? And you have to do all of that due diligence before, like, you can't just go in your logs and go, oh, like, this person's attacking me, so I'm just going to take them down, right? Like, there's a lot of coordination, a lot of research that has to happen before you do that. Mm-hmm. And the question we've talked about a lot lately is it physical retaliation? Is it cyber retaliation? Is it a combination thereof? And that's tricky. Very tricky.
It's the end of the article. It says, postscript, my wife, who has an eye for understanding human nature, offered this astute observation on a key psychological dynamic at play when someone is suddenly exposed to the bleak, albeit banal, reality of how pervasive intelligence controls actually are. And I don't know what she said because I need to refresh. But I think what the article was getting at is essentially what we were getting at, is that
it's not simple.
It's not simple, and it's not something that you should. Maybe if you're a big organization, you do it, but
in collaboration with law enforcement.
In collaboration with law enforcement.
You don't want to create an international incident either.
Well, what you're doing is illegal, regardless of what your motivation is, and you could end up getting in trouble. So yeah, you want to.
You can violate the CFAA yourself if you retaliate, right?
So it's not certainly anything that I would ever recommend. I think that's my position.
Yeah. The code. Do you remember the code Red Worm?
Yes, I do remember that.
I thought it was. This is a kind of a positive thing for me, right? The article from I think it was Sophos Security, right? Was the code Red Worm 20 years on? What have we learned? The article really didn't talk about what we've learned so much as describing the history behind code Red, but they did say something interesting in that if you can find a stack-based buffer overflow, back in the day, it was very, very little work, maybe an afternoon's worth of work, to weaponize it, use the paramilitary terminology that cybersecurity seems to like, and turn it into a workable exploit that could basically break in on any similar Windows system. I think it's props to Microsoft, many other software providers that have raised the bar, right?
Right.
Although we talk about the printer exploit, I did have a Twitter kind of thing that talked about weaponizing, that. I don't think that's a blanket statement, but in general, large software vendors like Microsoft have made it much harder to weaponize and exploit a vulnerability. When we think back to Code Red, like, it was the reason why Code Red spread so fast, because there were very little protections. There was a very glaring buffer overflow exploit.
Right.
And even if we have that today, there are protections that help us, but not in every case.
But it goes back to what I was saying earlier. Even though they're rarer these days, more complicated, it still boils down to, can you detect it and respond to it
And patch it.
and patch it, or just address, stop the people from doing it. Yeah.
Also, Microsoft discovered a threat actor targeting SolarWinds ServeView FTP software, which I thought was interesting because when I worked at university, ServeView was a ripe attack surface. Like attackers were using it as software to distribute wares back in the day, and ServeView was very vulnerable at the time. And I think it's interesting that we fast forward 20 years and people are still finding new attack vectors in it, and somehow it was tied to SolarWinds, which is interesting. It does SolarWinds make ServeView? Again, this was one of the ones I didn't dig into in any great detail.
They probably acquired it.
Yeah, who owns ServeView software?
I don't.
There was a 0-day exploit in it. It just brought me back. Oh yeah, SolarWinds FTP software. Yeah, SolarWinds distributes the software. Yeah, kind of interesting. It was a throwback. $528 per server, according to SolarWinds, to run vulnerable software. Imagine
that. So what have we learned today, Paul?
Lots of stuff. Great show. Good interviews, good news stories. So, Jeff, thanks for coming in studio, being here with me. Thanks everyone for listening and watching this edition of Paul Security Weekly. That concludes the show for tonight. Over and out.